As I said in the previous classes that we will explain about this formula. So now in this video of few minutes we will discuss about this formula, and this is very important for critical structures. And what are the critical structures like nuclear power plant, satellite communication center as the code mentioned. Now let us discuss about the K1 factor, and we have already known from the previous videos that K1 is the probability coefficient, that means the risk coefficient. So we have to assume the risk coefficient, and the risk coefficients are depends upon various probability such as degree of reliability. We will talk about the degree of reliability and the service life of the structures. Okay. So degree of reliability actually the level of confidence based upon which a structure will sustain its design life. That means as an engineer we have to design a building depending upon a level of confidence that the structure will sustain within its design life. Suppose we are designing a structure for 100 years, then it will sustain for 100 years. If it will unable to suspend, if it is unable to sustain less than 100 years, that means it is an engineering failure. So the degree of reliability is actually an engineering term. We have earlier from the same perspective we know the terms that degree of serviceability and degree of reliability. That's are the common terms used in engineering. It is not an actually engineering term, it is actually using in any perspective. So degree of reliability and service life. So now for important building, the return period is like 100 years to 1000 years. So within 1000 years, suppose a structure is designed for 50 years, and we have, that means once in a while design wind speed exceeds its designed value within 15 years once, and within 100 years it will happen in two times. That means within 50 if within 50 years the accidents happen since one time, then within 200 years it will happen in two times. That means the level of risk will gradually increasing. So we have to take more safety. So for important we have to assume it for more safety. So that's why that's why the value of K1 for important buildings is gradually increasing 1 to 1.06, and for 15 years design life, the risk level is lower. So that's why the K1 value is gradually increasing for critical structure, and for ordinary building it is generally assumed as 1, and for 50 years is generally assumed as 0.94. Now come to this formula. Now come to this formula. A minus B ln 1 by n ln p by p1 minus p divided by a plus 4b. A or b are the constants, and IS codes has mentioned the A or b values depending upon the various zonal wind speed. So n is the mean probable life, Pn is the risk level of n consecutive years of the probability of occurrence in n consecutive years. X and P is the extreme wind speed within n years of probability Pn, and X 50 0.63, generally 0.63 is for normal ordinary cases, so we can take it as standard. So before knowing this formula, we have to know the basic formula. K1 is ln divided by 1 minus P0 and ln 1 minus P. P is the probability of exceedance, P0 is 0.63, and design probability of ordinary building. So longer the design life, longer probability of exceedance. The larger probability of exceedance, that means it will in 50 years, if the probability of accidents is 1, and within 100 years the probability accidents is 2 times and gradually increasing. So for critical structure, for critical structure the risk level is gradually increasing. That's why the K value is gradually increasing. So now I have taken an example from the code that for 33 meter per second, A value is 83.2 and B value is 2.9.2. So we can easily calculate this formula. So this is the explanation of this formula.